All right, first off, welcome to our presentation. Just a quick intro. The modern world depends heavily on technology, and the making of that technology stems from careers that involve engineering. So today we'll be covering both of these topics, modern day technology and engineering. Just a quick intro for our group members. We have Abdullah, who's presenting Robotic Engineering. We have Jack with Autonomous Vehicles, Darren with Renewable Energy, me with Analysis of Wind Turbines. We have Anush with Game Theory Analysis. We have Natural with Social Engineering, Jaden with Ransomware, and Sion with Engineering Applications.
Hello, my name is Natural Taylor, and I'm here to tell you a little about our employer and team. Our employer is On-Ramps Virginia Tech, and our department is the Thinkbit Lab. At Virginia Tech's Thinkbit Lab, we're led by our head supervisor, Jim Eggenreiter, the alumni supervisors who participated in the lab last year, and other mentors, Rowena and Jing. At this lab, we're assisted by them to work on cooperative and individual research projects. Our work is important because we explore and develop our passions, which helps us become career ready and starts us on our professional paths. At Thinkbit Lab, one motto is that as long as you're doing something that you're interested in, that's time well spent. One interesting feature about Thinkbit Lab is that the actual physical lab on the Vtech campus has a variety of tools and machines to bring our ideas to life.
Hi, my name is Abdullah Cisse, and my project is Robotic Engineer. A robot is a non-functional manipulator designed to move materials, parts, tools, and/or specialized devices through various program motions for the performance/task at hand. Robots are mostly used for jobs that are repetitive or dangerous for human beings. Like in the top right picture, the decimator robot, it cleans and pumps housings in the nuclear power plant. Robotics are the design, construction, and operation of a robot. The goal of robotics is to design machines that can help and assist human beings. Thank you. That is the conclusion to my presentation.
Alright, my name is Jack Johnson, and my project for this internship was autonomous vehicles. And autonomous vehicles are robots or vehicles in general that are able to move on their own without direct human input. So you can still have humans sort of setting where it's to go, but the human is not controlling it. It is running by itself for the motion. These vehicles are often controlled remotely by following a set course that a human makes, and this ability to move without direct input or supervision makes them good for mundane repetitive tasks like an assembly line, or dangerous tasks that would endanger human beings like bomb disposal robots. This project is making an autonomous catamaran which will be able to go around and collect environmental data, then come back to its point of launch or wherever it needs to go. This could be useful for general surveying, collecting data over long distances, and going in places that are hard to reach with traditional equipment.
Hi, my name is Darren, and I'm here to tell you about the renewable energy. Renewable energy is energy that comes from natural sources such as sunlight, wind, rain, tides, waves, and geothermal heat. Things such as solar panels and wind turbines would be great examples of renewable energy since they don't burn off emissions and are very good for our environment to be used. As climate change is talked about around the world, we can only assume that things will only get worse unless we slow down our carbon footprint. To combat this, companies are starting to go green and push more electric use instead of burning emissions like gasoline. For example, companies like Tesla are making electric cars more affordable and consumer-friendly, while offering incentives for getting solar panels on their homes, such as tax write-offs or even free installations. I use Tesla as an example because they are one of the most well-known electric car companies that are pushing us to the right direction to become a much better and greener society.
Alright, so welcome to my slide. Today I'll be talking about the analysis of wind energy. More specifically though, how does the length and angle of a wind blade affect its electrical output? So first of all, a general definition, we got wind energy, and that's defined as a process by which wind is turned to mechanical or electrical power, typically through the use of wind turbines. And so the way this works is that obviously wind hits the turbines, it spins the turbines. That rotational force leads to the middle of the turbines, also known as the head. So as the head spins, that energy is transferred into a generator, which makes electrical energy, and that electricity is distributed through conductors that are then spread out across the city. So a couple pros about this is that it's clean, it's renewable, it's efficient in terms of land space. But some cons about it is that it is expensive to set up, and it has low energy density, meaning that it's not as efficient as, let's say, non-renewable energy sources. So, right. So, the second part of my slide of my presentation is a more specific part. But let's start with the length of the wind blades and how that affects its electrical output. Basically, the length of the wind blade and its electrical output have a linear relationship. So, as the length of the wind blades increases, so does its electrical output. Bigger blades means a bigger surface area that the blades will cover, meaning, how blades spin in a circle, and that circle that it creates will be bigger, and that'll catch more wind. And if there's more wind, it'll be faster, therefore spinning the head faster and generating more power. As for the angle, that's a bit more complex, but I'll be talking about the angle of attack, and that's basically the angle of the blades relative to incoming wind. So with this, engineers have to find a sweet spot between efficiency and drag, and usually for the standard wind turbines, that's about 10 to 15 degrees of angle of attack. But of course, that depends on the size of the wind turbine and the wind speed and whatnot. But thank you for watching.
My name is Anush, and today I'll be presenting game theory and what it is. So, basic overview of game theory is that it was invented by John von Neumann, who was a poker player. So he wanted a theory that could be used for anything, a mathematical theory that could be used for anything. So this game theory is actually applicable to diplomacy, war, different business strategy, economics, computer engineering, and so on. So essentially what it is, it's how we originally thought of it was as any economic situation is the outcome of a game, so-called game, between several players. So a game is made up of players, strategies, and payoffs. So of course players are different people or different entities involved. Strategies are different ways in which interactions can happen. And then payoffs are the rewards and consequences of an interaction. So originally game theory was based on zero-sum games, which essentially means that one person's loss is equivalent to another person's win. So there can only be one winner in a zero-sum game. And game theory was originally popularized by the prisoner's dilemma problem, which was a thought experiment involving two prisoners and whether they should confess or not. And then the decision-making behind it is the game theory. So the functionality is it uses lots of math based on matrices, and matrix-based math. And however, there was also lots of criticism of game theory because early versions assumed that players would only use logic and not make illogical decisions. Additionally, another criticism is that the zero-sum game is unrealistic because there could be a scenario where there would be multiple winners.
Hey there, it's Natural again, this time here to present you my project, Social Engineering. First off, I'd like you to picture a hacker. You're probably thinking of a guy in a dark room with a hood on, up to no good on a computer, much like this image. I beg to differ. Modern hackers can look just like you and I, and can even do most of their hacking in broad daylight. The thing I'm talking about is social engineering, which is a form of hacking in which an individual uses trust built with targets to breach security networks. Social engineering is very targeting and personal, and therefore is a big risk to companies. It doesn't matter how good their security systems are, all it takes is one employee to give up vital information to the wrong person, and it's all over, there's a breach. Spear phishing is a popular form of social engineering, which is a popular tool. You could get spear phish attempts in emails, which is a very popular form of communication that hackers like to use. 97% of malware tries to trick the user through a social engineering scheme, which is from a very credible source, a security company called KnowBe4. So next time you think of a hacker or being hacked, no, you can be hacked anywhere, by any place, and by anyone, even someone who seems nice. And just like they're doing something normal like opening a door for you, it could be a scheme to try to get your trust and infiltrate your company or your own personal data.
Hello, my
Hello.
Hello, my name is Jaden McClellan. This is about ransomware. Ransomware is used to steal data and sell it back to who they stole it from. A real-world example of this will be earlier this year when CD Projekt Red got hacked and had to buy back their files or be spread across the dark web. Most systems have basic protection from ransomware. Another thing you can do to protect yourself from ransomware will be to limit downloads, make sure to limit emails, and emails only you know and know where they came from, and keep everything up to date. Thank you for your time.
Hello, it's Natural again, here to present for Sion Robinson. Sion's project is being an engineer. Engineering is a term often used when describing a future STEM career. There are many types of engineering, including civil engineering, environmental engineering, which is actually the kind of engineering I plan on specializing on, mechanical engineering, chemical engineering, electrical and computer engineering, industrial engineering, systems engineering, biomedical engineering, and architectural engineering. Just the volume of engineer types on this list shows that there are many different options to choose from when you want to choose engineering as a career path. Fields especially like biomedical engineering and environmental engineering overlap a lot with other professionals like doctors and environmental scientists. So being an engineer can take you down a path where you'll meet a lot of other professionals, and overall you'll need to value teamwork as an important skill.
First off, I would like to thank everybody for watching our presentation. But before we end the video, I would just like to add a couple extra points. So STEM is very important because it leads to innovation that pushes the boundaries of technology, and that overall would then improve the quality of our life. Because of this, our futures will be directly impacted by new technologies, including the ones that we just discussed, such as renewable energy sources, autonomous vehicles, engineering, and many other topics. So I really hope that we left you informed about the topics that we discussed today, and that you learned something with us.